It is the first day of DeepSeek's 5 days of open source releases, and in keeping with their word, they have gone ahead and dropped the first of 5 open source repositories. We're going to jump right into it because this is pretty cool. It is a bit technical, but we're actually going to be able to get some hands-on experience and play with it. So we can see on this GitHub page right here, all of the open source releases from the upcoming week are going to be listed. Being that today is day 1, we can see that we only have one, which is FlashMLA, the first of 5 open source drops for this week. I will be honest with you, when I was expecting a drop to come out today, I was really kind of fingers crossed hoping it was something that's like a model you download, spin up a Gradio web interface, you just install it in a Conda environment, and it's kind of simple to use, and boom, video's out, cash in on the hype. No, but really this is something that I was like, oh wow, this is really kind of intricate and in-depth. However, let's take a look at it, get acclimated with it, and then we'll use it and see what some of the more broad-reaching ramifications of this open source drop are. FlashMLA is an efficient MLA decoding kernel for Hopper GPUs optimized for variable length sequences serving. Very technical, very technical sounding. However, to put it in more layman's terms, essentially what this is a way to increase speed and efficiency of NVIDIA Hopper GPUs. Now, a Hopper GPU for us mortals is more commonly referred to as something like the H100. Unfortunately, and kind of just get this out of the way up front, you do need a Hopper GPU to actually go ahead and test this repository. I know that for 2 reasons. One, because I tried it on a 4000 series just kind of for giggles, and it completely failed. And 2, because I actually do have an H100 that we are going to be able to test this with and actually kind of see some of its speed and performance. So that leads me to the next part, which is thanks to the awesome folks at, no, I'm just kidding. I just rented one on RunPod, so I have a cloud server running through RunPod with an H100 SXM instance, which will allow us to actually basically just run through this repository, install it, do the benchmark test where we will see some very fast memory bandwidth speeds, and then we'll go ahead and kind of see how that compares to some of the current things we're used to using as local LLM fans like FlashAttention 2 and things like that. Really, this repository is a bit sparse in terms of perhaps what we may be used to seeing when it comes to GitHub repositories that allow us to run intricate models with big readmes and instructions and things of that sort. However, this is actually quite simple to install, set up, and get running, assuming that you do have a Hopper GPU. So I do have my cloud instance from RunPod right here set up and open. And in keeping with the fact that I cannot type while I talk, I'm just going to butcher that, but we will check real quick and kind of see what graphics card we have available to us right here, which is the NVIDIA H100 80 GB or 80 gigabytes of video RAM, HBM3. This has a maximum power draw we can see of 700 watts, and they do specifically mention some SXM5, which is, for the purpose of this video, let's not worry too much about what the words after mean. This is testing this on an H100, which of course is a Hopper GPU. With that out of the way, we can see there are a few other kind of requirements here, one of which is the Hopper GPU, which we have now covered, CUDA 12.3 or above, and PyTorch 2.0 and above. Fortunately, I was able to deploy this container really quite quickly with a kind of pre-configured configuration, which had all these requirements met, so it wasn't really much work to actually go ahead and move on to the next step, which is just kind of running through this quick start. So we are first and foremost going to just clone this GitHub repository as such, which you are likely familiar with if you're still watching this specific video. And to do that, we will just type git clone and then paste in our repository name, which is called FlashMLA. Following that, we are just going to navigate into that repository. And once we've done that, we are going to go ahead and actually just run the installation script, which will go ahead and kind of configure all of this to be able to be run on our H100 system. Sorry, I've been up for kind of a while, so if I get a little loopy, that's why. And it does that. Takes a little bit of time, obviously, depending on network speed and things like that. However, this is a cloud server that I'm renting from RunPod right now. I think it's about $3 an hour to rent this specific one, so perhaps expensive. However, for some lightweight and demonstration purposes, I think it is a totally palatable expense just from an educational and hands-on experience point of view. When the installation is completed, we jump down to the benchmark section and run this test script. Now, this is a rather kind of technical implementation, but for the purpose of this video and kind of more appealing to a general audience, we can basically think of the whole concept of this as more efficiently utilizing the available resources of, in this case, this H100 GPU. So we can basically go faster, leading to faster inference and hopefully the eventuality where things like this trickle down to be able to run on consumer 3000 or 4000 series cards like I'm sure a lot of us at home are using. So as we run this benchmark script right here, we are basically going to see a lot of printouts on the screen as this runs. And basically what those are is what it says right here, where we test the max speed we can get in a memory bound configuration and in a computation bound configuration. So we're going to press enter right here, run this, and we are going to see some rather high speeds. And again, if you see a lot of numbers here, but don't really necessarily have a way to actually parse what these mean, perhaps for your own setup at home or something like that, we are actually following this, going to go ahead and just run a similar style test using FlashAttention 2 on my local laptop right here with a 4000 series GPU. So we will be able to get some level of idea of what these speeds would actually be for a consumer and hobbyist kind of setup. But we can see this runs for a set amount of time and then concludes, so you don't have to worry about like huge memory or power draw utilization if you do have an H100 and are going to be running this locally. But we can see that it starts off and we are in a kind of memory bound ceiling example here, so we can see how fast we are actually getting the bandwidth to be utilized. Unscientific, but really, I think the highest I see here so far is 2810. We scroll down and we can see that following that, the values kind of begin to shift and the compute bound situation, again, non-scientific, begins to be more drawn out. Oh, we can see, okay, we have 2,975 gigabytes a second. And if we go, what is the highest T-flops that we have seen? I see 532. And so 532. Now, basically, again, if you're not already kind of familiar with a lot of this terminology, this kind of probably looks like a foreign dialect because we don't have a reference point for this. And that is really kind of what I want to do now, is just essentially go ahead and run a very similar thing on a local computer of mine right here, which is a laptop with a 4060 GPU. I now want to do a speed test on my actual consumer 4000 series card here. However, to do that, we have to use FlashAttention 2, which is something you have likely interacted with even without knowing it if you have run local LLMs or things like that. I want to give a background example of what these are so it makes sense when we actually go ahead and actually see these speed readouts. But in order to do that, I think it is best if I do it metaphorically. So bear with me, but I'm going to try my best to kind of put this in an understandable way. FlashMLA right here. If we go into this tests folder and we click on this, we will see the actual test script, which this is actually what we just ran right here when we saw all of these speed readouts. Now, imagine that both FlashMLA and FlashAttention 2 are very fast roller coasters. However, they each have different limitations in terms of how much they can actually carry. So bear with me, and this is non-scientific, but if we scroll all the way down here, we're going to see this value right here, which is 576. For the purpose of our explanation, let's assume that FlashMLA is a fast roller coaster that has a maximum passenger weight of 576 pounds. So if you're 576 pounds or less, we fit you in one seat, you're good to go and ride the roller coaster. FlashAttention 2, which is what we're going to be testing right now, a little kind of test script using FlashAttention 2, can be thought of as another fast roller coaster. However, it has a limit of 256 pounds for any rider. So if our rider is over 256 pounds, unfortunately, they're going to need to be seated in more than one seat. So we kind of have to chunk them or break them up, therefore making things perhaps less efficient, because then say we can't fit as many passengers in the roller coaster if we have one over 256 who needs to take up multiple seats. Again, this is unscientific, but basically the whole point is that when we run this benchmark right here, it is not only going to be slower, but I want you to understand that FlashMLA is actually carrying heavier passengers and getting the speeds that we saw when we actually ran that test script. Now, what I'm going to do is just copy the script in right here and paste it. Now, you will see that it says cat right here. The whole reasoning behind that is because this cloud instance that I'm using, I can't just use nano and paste it in as a Python file. So I have to do it this way, which is a little bit odd, but it kind of works for now. So I'm going to try again to paste this into my RunPod cloud instance right here. And if I press enter, good, it did work. And we are just going to basically run this benchmark. And then once we do this, we're actually going to run the same exact thing on the Consumer 4000 series GPU right in front of me, just to kind of get an understanding of how much faster these data center cards are, I guess, which can be a little depressing, I suppose. But we are going to just copy that and run it using Python and then flashbench.py. And we will see we get one speed readout right here, which is 1,398 gigabytes per second, and the T-flops are 44. I wouldn't really necessarily directly worry about comparing those or really any of this, but just know that, okay, this is a bit slower and it is carrying a much lighter passenger, whereas the actual FlashMLA that we looked at before, the DeepSeek open source release that just came out on day one, was not only carrying heavier passengers, but it was much faster. However, these are not directly comparable speed-wise, but I did just want to run this on the cloud instance with the H100, because now when we run this exact same script on our local machine, we will kind of just have a reference point to the actual speed that we see. And that's basically what we're going to do right now. So I do have this script open in Visual Studio Code on my local machine. Maybe I'll put this on like a GitHub gist or something, so you can basically just download and run this on your local machine and kind of see what speed you get, which may be kind of fun and just kind of a more hands-on way to actually see some of this. So we just want to make sure that when we actually have this running, the flush fast is false and it's not enabled there. Okay, ignore what I just said. This is all set to go. So I'm going to run this right here and we're going to see what speed readouts we get on this 4060 8 gig laptop GPU. So our bandwidth was 106 gigabytes per second and the T-flops readout was 3 as opposed to 44 and 1,398. Now, this is simply designed to show a reference of like, okay, I want to see how my local device does with this because I don't really understand these random large numbers without a reference point. So I just wanted to do that as kind of a reference point. And this is also a fun small thing you can actually run at home on your local machine and see what goes on here. I think this is kind of an abysmal number. And what I am actually going to do later is just really quickly test this on one of the 3090s over there, just to kind of see if I can feel a little better about my setup. But I wanted to do that just because this drop is rather technical and kind of hard to understand for perhaps those who are not like math PhDs or machine learning PhDs. But basically the whole point of this and why this is cool is that it more efficiently utilizes the available existing graphical resources, which can allow for faster speeds, which mean that you can serve more people at the same time, or you can more efficiently utilize what you have. While this doesn't currently run on 3000, 4000 series GPUs, it is something that will hopefully trickle down just to folks like myself who will be able to then actually just find more optimizations to use these models on the existing GPUs we have. If we scroll down all the way down here as one of kind of the last things to do, we can see that there are some acknowledgements here. And one of the acknowledgements is for FlashAttention 2. However, FlashAttention 3 is also mentioned here. And that is kind of something where you could do some more reading about if you were so inclined, because we do actually see there's a graph here. Sorry, let me kind of speed this up, where they show FlashAttention 3 speed compared to FlashAttention 2, and we can see FlashAttention 2 is the little orange bar right here, FlashAttention 3 is the purple bar. These are things that are going to come to us in the future, and this is just all about speed and efficiency. To sum this up, I want to say that I was hoping this would just be something like, ooh, here's a multimodal model and we're going to download it in a Conda environment and just run a Gradio web interface, boom, and it's easy to run. But this is something that is kind of more in-depth and very math heavy, I suppose one could say. So I wanted to give a really kind of hands-on explanation and example of this to the best of my ability, which basically just was running this on the actual hardware that is listed as a requirement to use it, which thanks to the RunPod instance I rented was an H100 GPU. So that is day one of DeepSeek's 5 days of open source, and I will be back to cover day 2 when it does drop, which is, I mean, this was, I do want to point out, this is kind of braggy, I know, but I was actually the 5th person to start this repository on GitHub, so I'm very proud of that. I will pat myself, I'm just kidding. So yeah, I'll catch you probably tomorrow night or something like that. I hope this made some level of sense and perhaps is something you can then go ahead and just kind of test on your local machine. I'll put this script on a GitHub gist so you can see how fast your bandwidth is.